Okay, this is going to be one of maybe a couple of lessons that I want you to watch in your own time on YouTube. So we're at page 25 of the electricity circuit booklet, and we're looking at the cost of electricity. So a unit of energy that we want to look at is the kilowatt hour. Now a kilowatt hour, it is a unit of energy. We know that energy is power times time, or the rate of energy per unit time multiplied by time. However, what we require is our units of power need to be in kilowatts, and the units of time need to be in hours. Okay, so 1 kilowatt hour, should be a bit larger, is equal to 1,000 joules per second multiplied by 1 hour, which is 60 by 60. It's actually equal to 3,600,000 joules. So really it is just 3.6 megajoules. That's equal to 1 kilowatt, and Synergy, the power provider, is basically charging the consumer 28 cents for every kilowatt hour that is used. Okay, so the cost, there's an equation for cost. If we could just write it down here, the cost is going to be equal to the rate multiplied by our kilowatt hour. Okay, so we can also just have rate multiplied by power multiplied by time. So we just have a very simple equation. We're multiplying everything together, power, time, and the rate. If we looked at, what do we got? We've got dollars per kilowatt hour multiplied by kilowatts multiplied by hours. You can see cancel-y, our kilowatts cancel with kilowatts, our hours cancel with hours, and we are left with a unit of dollars. Okay, so there's the dimensional analysis. So let's have a look. 300 watt projector. So what we need to do is convert our power into kilowatts, and we've got our time there as 5 hours. So we would have cost is equal to the rate times kilowatt hours. So we'd have 0.28 multiplied by 0.3 times 5. So obviously the kilowatt hour there is 1.5 kilowatt hours. Multiplied that by 0.28, which I haven't solved yet because the price of electricity has gone up. We are talking 42 cents. Or $0.42. So that's how much it would cost to run a projector. So just before we continue, sometimes we have off-peak cost. Sometimes it's charged as less, you might get around about 21 cents per kilowatt hour. In off-peak times, that might be between the hours of, say, 11 p.m. to 7 a.m. And then you've got on-peak, which would be 7 a.m. to 11 p.m. And generally, it's more expensive in these times. And that's trying to influence the consumer to be consuming electricity when it's cheaper and not consuming when it's more expensive. So things like turning on your pool pumps and your filters and your reticulation, laundry and things like that, dishwashers. If you can have them running overnight, it actually is a little bit cheaper because it puts less of a demand on the electrical grid during peak times. Let's have a look at an example here. A fridge obviously is running constantly. It has a power of 0.1 kilowatts, and our time running for a year, that's going to be 365 times 24 times 60 times 60. Okay. And so we'll give it a go. Our cost equals rate times kilowatt times hours. So 0.28 times 0.1 times our time. Now, before we go on, 0.28, let's figure out, let's just stop there and go, how many kilowatt hours does a fridge require? That's not right, because we don't want it down to hours. We don't want it down to seconds, we want it down to hours. Sorry about that little stuff up. We get 876.6 kilowatt hours. So that's quite a lot of energy. Each one of these values is charged at a rate of around 28 cents. And we get a cost of $245 to run your fridge for the entire year. Okay. Next, if you have a holiday house, and this is appliances that have a standby mode, they're still switched on, they're still activated, power's still running through them. Some of these things might be looking for a remote control to control them, so they've got a little sensor that's constantly looking for infrared. So imagine you had a holiday house and you leave that holiday house just sitting there, everything's still turned on, power is still being consumed. There would be a total power, adding all these numbers up, of around 19 watts. So if we divide that by 1,000, we get 0.019 kilowatts. And we'll do the same thing. Cost is rate times kilowatts times hours. $365.25 times 24, and we will get 0.28 times. Now this one's obviously not so many kilowatt hours, a little bit less. We get 166.5 kilowatt hours, and then we have to pay $46.6. So obviously it would pay to basically switch off at the wall. That's a picture of a switch. Turn off the power at the wall or at the circuit board to prevent you losing $46 every year. So there are some questions now you might want to be able to look at. So things like, there's a question here on kilowatt hours. Please get these questions done in preparation for the test on Monday. So that was just a very quick lesson on the kilowatt hour. It is a unit of energy, even though it has the word kilowatt. Power times time is energy. So a kilowatt hour is simply a big amount of energy which we have to pay for every time we consume that amount of energy. Okay, that's me signing out.